A homogeneous mixture of solvent and solute is called a solution. And the solutions are able to influence the water owing to the differences of their concentration. So today we are going to explore what happens when you place a cell in a solution that is much more salty, which is called hypertonic, and much more watery, which is called hypotonic, or lastly, the one that has an equal salt concentration on the either solutions, which is called isotonic. And as you all know that cell membrane is selectively permeable, so while big molecules or big particles are not able to penetrate, as you can see the cell membrane here, big particles such as like salt particles not able to penetrate to the other side of the cell membrane, while water molecules are the one able to move in and out of the cell membrane, and with no any expenditure of energy, without spending any energy. But however, there is still something that movement is depend on, which is called the concentration. So as you can see, the concentrations are not equal here. Salt molecules or salt particles are here, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, like just randomly. We have 8 salt particles here, but on the other side, we don't have it. So this part has higher concentration to the other solution of solute molecules or solute particles. And otherwise known as the concentration it refers the amount of solute particles per volume of the solvent. Or we can just say that whether the water is like more salty or more watery. And also this process, the movement of the water molecules through the cell membrane, whether inside or outside, is called osmosis, which is water molecules would flow from the higher concentration. Now you can see water molecules are in higher concentration here, which means also we can say less salt concentration than the other solution. So they move from the higher concentration to the lower concentration, because you can see here few water molecules are here than this solution on my left hand side. Finally, at the end of this process, they will reach equilibrium, which means equal concentration on either sides. So solid particles are big to fit cell membrane, so only water would move across the cell membrane, and finally they would reach equilibrium, which means the equal concentration on either side of the cell membrane, the equal amount of water, for example, on both sides. Now let's have a closer look at that. How the osmosis process takes place. As you can see here, this is just regular chlorine atoms and sodium. They are the one. This is actually sodium chloride. This is like table salt, and they are the one create this attraction with water molecules. Those are the water molecules. Those are the one attracted by the salt particles. Even these water molecules are going to be attracted through the salt particles. And finally, you are going to see salt has already attracted and water molecules stick on it, and that's what makes them to take take place, that process, osmosis. So the reason behind that, as you already know from chemistry, the negative ions on the salt molecules and the positive ions on the water molecules. For example, hydrogen has positive ions and oxygen has negative ions. Hydrogen has positive ions, oxygen has negative ions, and sodium has positive ions and chlor has negative ions. So positive and negatives are going to attract each other. Positive and negative, they are going to attract each other. So at the end, we are going to end up here. So according to this rule of attraction, then so that osmosis process is going to take place. And now we are going to immerse a cell in 3 different kind of liquids or solutions. For example, very salty liquid, as you can see, the salt particles are more, they're highly concentrated, they're more in number here. And very watery liquid, as you can see here, the salt particles are very few in water solution. They are very few, and so they're the less concentrated or watery solution or less concentrated solution. And lastly, a liquid that's in between. As you can see, the salt particles are almost equally scattered in that solution. So in this first scenario, liquids that surrounds the cell has so many solute particles here. So it is that kind of liquids are called hypertonic to the cell content. Hypertonic to the cell content. It's much higher concentration of solute particles and a much lower concentration of water particles, as you can see. Unfortunately, the molecules cannot pass through the cell membrane to reach equilibrium, but water molecules can do that. So water will begin to rush out of the cell. Water will begin to rush out of the cell, and then cell will shrink, as you can see. The cell is going to be shrinking like that, which is called coronation. Because this is an animal cell. If we use a plant cell here, it's supposed to be something like that, which is called plasmolysis. If we are talking about plant cell, this is plant cell. And once they lose water, once the cell of plant lose water, that is going to be called plasmolysis. But if you're talking about animal cell, once it loses the water, it's going to be called coronation. And now let's immerse a cell in a much less concentrated solution, a hypotonic solution, which is this one, a hypotonic solution. Hypotonic solution, compared to the cell, it is much less salty. As you can see, very few salt particles are moving around here. They're very few, really few. So less This solution we can call it as less salty. And the water molecules would be attracted by the high concentration of solutes. So high concentration is solute is in the here in the cell as the cell content. So water are going to be attracted by that solution from the surrounding. Now water water molecules are going to move into the cell, as you can see. So finally, and then finally, what we will see, what would happen there, water molecules after water molecules moving into the cell, then the cell would grow in size. Then the cell would grow in size. And lastly, the placing a cell in an isotonic solution, as you can see here, equally concentrated, equally scattered salt particles or solute particles in a solution, or the place where the concentration of inside and outside of the cell are equal. So that's much more pleasant, and the cell neither grow nor shrink, and it's much more likely to survive. That is osmosis. And now let's have a question about the topic. Then we are going to finalize it. Distinguish between hypertonic, hypotonic, and isotonic solutions. Hypertonic solution, as we discussed. Now you can stop video and try to answer by yourself. Be honest to yourself, and then you can continue again. You can pause and then continue. Now, hypertonic solution, as we already mentioned, it refers to a higher concentration of solute molecules than the other solution. As you can see, higher solute molecules than the other solution. And hypotonic solution is less concentration of solute molecules than the other solution. Less concentration of solute molecules than the other solution here. And isotonic means equal concentration of solute molecules to the other solution as well. As you can see, they're almost equally scattered here.